Good morning and good afternoon, and thanks for checking out our new conversation. Today, I'm talking to Ben Cardwell, the Senior Vice President and Segment Leader at CommScope Mobility Solutions. Ben, thanks for being with us today.
Thank you, Monica.
So our conversation today is part of a report on densification and on the evolution of the RAN in an environment where mobile operators need much more capacity to meet the demands of the subscribers like us, and also increasingly IoT applications, and as they're preparing to 5G. So Ben, can you tell us what is that in this context you do at CommScope, and what is it you're doing personally?
Well, operators generally have three tools they can use to increase the capacity of their network. And as we all know, wireless networks will need roughly 1,000 times the capacity they have today in 10 years. So the three tools they can use are, number one, to add more spectrum, which is very expensive and only comes along every several years, that opportunity. Number two, they can make the existing spectrum they have operate more efficiently. And number three, they can densify the network, really, right? Add more cells and bring users as close as possible, or even closer to a fiber hop-off point. So that densification piece, as you said, is key, and that will be the number one way that you see this 10,000x capacity come into the network over the next 10 years. So at CommScope, we have been doing densification for operators for a long time. So densification is nothing new. But it will certainly accelerate. In the past, we have, starting with the macro towers, which is certainly where the most efficient and economical way to start for the operators, they've been sectorizing their sites, right? So going from traditional 3-sector sites to 6-sector sites or even more. And we've been providing the tools and the know-how for them to do that. Once they get to that point, they've sectorized their macro sites, then they look to more in-building sites. So in-building has long time been a key avenue to densification. CommScope's been the largest provider of DAS systems in the marketplace over the last decade, and we've deployed countless public and private venues. And the third way, the third thing we've done is really working with neutral hosts and operators to deploy what we call ODAS networks, outdoor DAS networks, that can put loads of capacity on street corners and other outdoor locations in a very small footprint.
Right, and what is that you personally are doing in all this? This is a lot to do, a lot of ground.
Yeah, absolutely. So as I said, in the sectorization of the macro towers, we provide high performance antennas, filtering capabilities, and connectivity that allow them to further sectorize those sites. When you do that, it really requires a very finely tuned cell boundaries and eliminating interference, and that's one thing we do best. In the building space and in the ODAS outdoor space, we actually provide the DAS equipment and the design services and sometimes even the deployment services to do that.
Now, as I said, densification is nothing new. It's accelerating, but it's always been there. But initially, it was more for coverage, now more for capacity, but I guess that what densification is about is different because the technology is different, because the needs are different. How do you see it changing, especially in the relationship between densifying the indoor versus the outdoor? Is that changing?
It is changing, and operators will need to do both. They'll need to, cover more and more buildings from the inside out. In the past, they have focused mostly on public access venues, big venues where lots of people go. And those have been done, and those are big buildings, big systems. Going forward, we'll need to move into the second and third tier of buildings that are more in the 200 to 500,000 square feet type of size. These new systems will need to be much lower cost and be able to be deployable by a different type of professional, maybe an IT professional, instead of a RF engineer with 15 years of experience. So we've been focused on that in-building space, creating the platforms and the ecosystem to allow DAS to scale to a much larger audience. Also in that space, we've been developing world-class indoor small cell solution. We have a solution called OneCell that really provides a cloud RAN approach to in building, giving maximum capacity utilization in a building. In the outdoor space, there will have to be many more of these outdoor small cells, especially in urban and semi-urban environments, just to take the load, to carry the traffic load. And the biggest problems that the operators have in this space in doing this is that there are three major problems, and it's really getting power to the site, getting backhaul to the site, and most importantly, site acquisition. Site acquisition is becoming a major challenge, and that's something that also it does not scale well in the industry because it's down to what the locality will allow, right? And as we know, different regulatory or local approval councils have different requirements. So we're focused very much on creating solutions that allow scalability of this space.
Okay, so you raised a lot of topics that I want to follow up on. Let's start with the outdoors. So you said you're trying to help operators to address all these issues, the power, site acquisitions, and backhaul. How can you help them? What are the solutions here?
Yeah, so the site acquisition, again, being the number one challenge, it's really all about concealment and not creating an eyesore for the public, right? So we are creating cabinets and concealment solutions that allow small cells to be housed inside, and the antennas and all the infrastructure required for a small cell to be placed either inside a pole, under a park bench, in something that may look like a vending machine, something where it's really disguised from the public, and this becomes even more pronounced in the numerous historic districts in the U.S. where you really cannot see the requirements. You cannot see them at all. So we've done several historic districts where we've even replicated old-fashioned light poles that are from early century, even that were gas lamps on the street, for example, to conceal the infrastructure inside and enable the fiber connectivity to the site with our fiber solutions and even backup power in those sites for fail-safe operation.
Right, and as I said, that's really important especially because the requirements from cities are very different. You think that they're going to converge at some point, and we're going to have an easier set of requirements, or you're going to need always have sort of customized solutions?
I think there's going to continue to be a large amount of customization, but the more of these cities and localities we deal with through our partners, we are learning some of the commonalities. So we are working very hard to create some solutions that'll be a least common denominator, if you will, that'll more likely to be cited by various cities. And the other key to this is we're seeing operators and neutral hosts forming public-private partnerships with the likes of energy companies or other utility companies or the municipalities that actually own the poles. And you'll see in many cities the poles and the infrastructure tends to be common throughout that city or municipality. And we can create oftentimes 2 or 3 solutions that we can get approved and deploy in those locations.
And in this context, what's important? What is the relevance of the sort of system integrators in all this? Because obviously you're not going to go install it, and most of the time the cities don't either.
Right. We at CommScope we typically design and manufacture the infrastructure to make this happen. The integrators play an absolute key role. Both in and the integrators tend to know, the local integrators tend to know that environment very well. And of course, there's some national or operators in various countries integrators that understand the whole ecosystem, but generally the local integrators play a very key role because they have worked in that environment before, either providing the solutions to the utility companies or for the municipality. So they're very important as part of the ecosystem.
Do you think they're going to play a more important role than operators themselves in doing the installations?
In doing the installations, absolutely. I think because of the scale, right, and the number of small cells or densification points, whatever type they may take on, that are required, operators are not going to be able to do this all themselves. They're not going to be able to scale it with their own resources. So they're going to have to rely on partnerships in local partnerships and even some regional partnerships to do that.
Yeah. So you mentioned the ODAS and small cells for outdoors. What are the pros and cons of both solutions?
Well, you're right. They have pros and cons, and really, it's about the specific task at that specific site. So, operators will need multiple tools in their basket, basket of tricks to do all the sites that are required. So, the advantage of ODAS is really that you can bring loads of capacity into a very small form factor. Right? You can feed it with fiber. You can feed multiple operators. And you can feed multiple frequency bands to that one radiating point, a very small form factor that can be hidden. The advantage of if you don't need that much capacity at a particular site, you only need a few channels or a single operator, then certainly a small cell is a small cell or a remote radio head, a miniaturized remote radio head can be a very good solution. So it's all about looking at the economics for the task at hand.
Yeah, and I guess you want to have like multiple tools to address the requirements. So if we go indoors, same thing, right? So we have, this big, powerful DAS for like stadiums, but obviously that solution is not relevant for a small office. So right. How can you get DAS to adapt to the smaller venues? And again, what are the trade-offs between a DAS, even a DAS for a small office or a venue versus small cells?
Okay, so you're right. The DAS, we believe that DAS will continue to be the tool of choice for the large public access venues, the sporting stadiums, airports, the big high-rises, big shopping malls, things of that nature, where every operator and is going to want to be on that system, and they're going to have to throw every bit of spectrum they've got into those venues. As we get to the smaller venues, yes, we need new tools. And again, in these smaller venues, sometimes we've been evolving DAS, obviously. So DAS, the newer DAS solutions that we have, they plan, install, and commission and operate just like any other piece of IT infrastructure. So we can enable an IT organization, an enterprise, to use those. And those would be still economical, these small mini DAS solutions, if you will, for where you need multiple frequency bands or more than one operator. But where you get to a building like perhaps a corporate headquarters where the enterprise may be standardized on a single operator, and all they need is one operator in the building and maybe a one or two bands, then a small cell starts to make more sense, right? And those solutions also are becoming more enterprise friendly because, again, to get in building to scale, you've really got to tap into that enterprise ecosystem.
Yeah, and then I guess that there are some sort of in-between solutions where you have like a CRAN approach. So it's and sometimes it's not entirely clear. Is it DAS? Is it more DAS? Is it a small cell? And I guess it doesn't really matter how you call it, but it's a different functionality. So like your OneCell approach it's a little bit of an in-between between the two. Is that right?
OneCell approach, the OneCell approach, for example, would be what you might call a hybrid approach. It's not a standalone small cell. It's a collection of access points within a building that form a Cloud RAN. And really, we call this a managed Cloud RAN solution or intelligent Cloud RAN, intelligent small cell solution. So really, you have a system that can operate in a closed environment inside the building with the backhaul to the operator, and works and really can be deployed extremely cost effectively.
What kind of backhaul do you use for the in-building connectivity?
The backhaul would still be it's IP backhaul, but it would still go out and leave the building on a fiber.
Yeah, so fiber from the building, and then is it Ethernet within the building or IP based?
Yeah, it's within the building. It's generally standard twisted pair Cat5 or Cat6 cabling that would be in that building anyway.
Right. Now, operators are looking more and more into using unlicensed bands, and it could be, as they're doing already, Wi-Fi, but also LTE unlicensed, so LTE-U, LAA, multifier. What are you seeing, and what are you doing on that front?
So we believe that those unlicensed bands will be very important because, again, spectrum is one of the most valuable assets. Using that unlicensed band will be key. We believe that the signaling, the pieces, the part of the network that controls the call will pretty much always, we expect that to always be in a licensed band because the carrier needs to control that very carefully. But the newer technologies like LAA or LWA will actually allow the LTE protocol to take advantage of some of that unlicensed spectrum, grab it, use it while it's available, right, and be able to ramp up and down the use of that dynamically. So we think that's going to be very, very key to have that kind of on-demand use of licensed spectrum. So when you do that, it only adds to the complexity of the RF network. Our expertise at CommScope is really managing that RF interference, and we believe we're the best there is at understanding and mitigating the interference in the RF layer of the network to make all those bands work together efficiently. So we'd be creating DAS solutions and antennas and connectivity infrastructure to make that to minimize all the interference in the building. And in the outdoor space, the same thing. We'd be working to create the antennas and filtering solutions to make that most efficient.
Yeah, and that's interesting because interference obviously is nothing new, but for a mobile operator to manage interference in an unlicensed band, or to manage capacity for that matter, in an unlicensed band is an entirely new endeavor.
Yeah, exactly right.
And many operators are a little bit nervous of how to do it because still they have the licensed band as an anchor, but there is still a lot of challenges there. What are you hearing from operators? Are they worried, and how can you, because obviously interference in an unlicensed band is something you can manage to some extent. It depends on what else is going on at the same time.
No, that's correct. And even interference has become a much more serious and pointed issue now that LTE has been deployed, right? Mm-hmm. In spread spectrum systems, like LTE and even CDMA, and UMTS, as we move up in the G cycle, right, 2G, 3G, 4G, interference becomes more and more important. One is because the traffic on the network is getting higher, mm-hmm. but number two is because you're trying to get more and more speed out of this fixed frequency resource. So you've really got to fine tune and clean up that spectrum as best as possible. Every antenna's got to have a very clean targeted pattern covering the areas and not overlapping with its neighbor. So we're managing that type of interference, plus just the normal interference that can come from the environment of operating a mobile network, creating products that are easy to install, that work well together, so that even in the interface points between the different pieces of equipment in the network, you're not creating opportunities for an installer to create interference when you connect them together.
Yeah, and as you say, one of the crucial things as you move indoors, especially, you need to be friendly to the enterprise. in the sense that they need to be able to easily fix problems if there is something, or to have an integrator come in. How do you see the role of the enterprise in all this changing? Are they going to be more involved? Are they going to pay for the infrastructures themselves, or how is that going to work out?
Well, it's a very good question. That is extremely important, that we enable that enterprise ecosystem to be somewhat self-sufficient. Now, the carrier is going to always have to play a key role, because it's the carrier's licensed spectrum we're talking about, and they will always have to be comfortable with whatever is radiating their spectrum. And it's their at the end of the day, it's their customers. If your cell phone doesn't work, I'm going to call my operator and probably be the one that complains. So we're working very hard to create the products, right, that are friendly to the enterprise, but acceptable to the operator, and more importantly, create products that are extremely simple to design, deploy, and install, so that those the much larger market of IT engineers are comfortable working with these and can install them reliably, right? So it's not just about the IT people in the building. It's about the ecosystem that feeds them today. We have to enable that ecosystem, because again, we've got to scale to not just doing thousands of buildings a year that are done today with DAS. We got to scale this to tens of thousands, or maybe even hundreds of thousands a year of buildings that can be deployed. We believe there's 5 billion square feet of opportunity out there, uncovered commercial space out there that needs to be covered. The only way we're going to do that is by enabling that ecosystem, and we're working very hard at that.
Yes, absolutely. And, again, scalability, it's crucial here. Now, one other trend is virtualization. Is virtualization going to help scalability?
It will help scalability. It will definitely help improve the ability to deliver 5G type services. And we already see, and I think it's a road, it's a journey to virtualization for the operator. They're starting with some very simple things like really centralizing the baseband capabilities of the network. So you might remove today in most cell sites. The baseband is sitting at the bottom of every tower, dedicated to that tower. Sometimes it's heavily utilized, sometimes it's not utilized. So if you take a cluster of a dozen, 50 sites, whatever, and take that baseband away, move it to a centralized point, and make it available to all those 50 cell sites dynamically. So when there's a football game going over here, you can shift all the traffic over there. If it's rush hour and the traffic jam, you can shift it all over here. So we see that starting to happen already today. So that's step number one. And then the next step would be, from a capacity perspective, virtualizing that. So moving it farther back in the network and putting it putting software-based servers, and really making it even available dynamically to larger chunks of the network. So we think this is a migration that will happen over the next 5 years as people prepare for a new barrage of 5G traffic. Right.
In closing, can you tell me what is that you're working on at CommScope right now to meet the challenges over, say, next 5 years? We can't really see farther out in telecom. So what is coming up? What is it we should expect from you?
Yeah, absolutely. So at CommScope, we have two very key technologies that are going to be really the fundamentals of the 5G network, right? In the next generation network, as the wireline and with the broadband and wireless networks basically converge, customer won't be able to tell or care whether he's on a fixed network or a wireless network. He'll get the same type of service from both. And we believe that wireless and fiber are going to be the two big enablers of that converged network. We are the leaders of both, right, in the layer of the network that we operate. So we're creating solutions that are going to drive this centralized CRAN and virtualized RAN network, right? Because there's going to be a lot of fiber in these networks, and there's very few people know how to do this as well as we do, as it relates to a wireless network. And then for at the very network edge, that wireless access layer, we are working with our industry partners to create the same types of infrastructure we have in the past. Smarter antennas where they have more intelligence in them. Things like massive MIMO you'll see being a big play where you have actual beamforming, and beamforming helps further reduce that interference in the network. And then on the in-building front, designing the next generation DAS systems and small cell solutions that, again, scale to that ecosystem, that enterprise ecosystem we were talking about. We think that's a big opportunity that's largely untapped out there.
Yeah. And yes, there is a huge opportunity there. It's the fiber and wireless put together. Ben, thank you so much for your insight and talking to us today.
Thank you so much, Monica, for having me today.
So this conversation with Ben Cardwell at CommScope Mobility Solutions was part of a report on densification by Sense of Feeling in collaboration with RCR Wireless that you can download. And thanks all for attending.